All right. Good morning, class. I appreciate you all coming in. It's a little bit different of a Tuesday. We had that TA session. Hopefully everyone made it to that. But this week we're going to start by backing off of what we did last week. So last week we were talking hand tools. We did all of our quizzes. We did things like that. Hopefully we all did well. I've yet to check those marks. I wanted to give everyone the chance to get them in before I went and looked at them. But today we're going to start talking about power tools because we need the power tools in the shop because hand tools are fun, but they do take a long time. So we do have power tools in the shop to make things easier for us. It's a nice thing about being an intelligent species. We find ways to make things easier. So we make tools, we invent tools, and we got some basic ones in the shop that are pretty nice. They're very useful and they're going to save us a lot of time. So we're going to go over some of those today. I think we got half a dozen basic tools in the shop that we're going to go over, and I have a slideshow for that. So I'm going to share my screen and I'll open up that slideshow. And what we're going to do is we're going to pop this out of here. Open Google Slides. And then we will present this. All right, just a reminder, if you have not dropped your name in the chat yet, please do so. All right, but here we go. Power tools in our fabrication 1010 unit. So the objectives we have are going to be describe and demonstrate the safe operation of a bench, pedestal grinders, angle grinders, and straight grinders. So we got lots of different grinders. We shape and form steel in many ways in here, whether it be, with a hand grinder or with a big pedestal grinder in the shop. So describe and demonstrate the use and safe operation of portable power drills, drill presses, and twist drills. So we got multiple ways of cutting holes and things as well. We can also use other things to cut holes in the shop, but this is kind of pertaining to the machines that we use. Describe and use the safe operation of metal forming and shaping tools. We don't have too many metal forming or shaping tools in here, but we do have some that we need to know about. Identify and describe procedures for cutting metals using shearing machines, cutout saws, and metal cutting band saws. So we do have a metal cutting band saw. We do have a foot shear. It is not a powered shear, but we have a foot shear we can use to cut thinner sheet metal. So we're going to talk about grinding. There is a lot of hazard associated with grinding, and we're going to try and mitigate that by going through this PowerPoint for you. So most accidents occur because of tool misuse. It's not the tool's fault. It's not the grinder's fault. It's not the weather. It's not whatever. It's almost always the operator using the tool incorrectly. Now, I'm not saying it's every time, but there are times when tools are damaged. It can hurt people, but incorrect use of the tool is almost always the root of the problem. Two important considerations are to use the tool as it's designed to be used and keep your mind focused on the job. So use the tool as it's designed to be used is important because when we get to things like pedestal grinders, hand grinders, angle grinders, stuff like that, there are different discs we can use for different jobs. Now, just like a crescent wrench is not the best tool for working on a car, maybe a zip disc is not the best tool for grinding. So grinders have different discs, and we need to match up that disc to the job we're doing. Otherwise, there could be some unwanted side effects that could potentially put us in harm's way. So general grinding safety is always wear goggles and a face shield and hearing protection while grinding. So safety glasses, non-negotiable. It is a must always in the shop whenever there is even one single power tool on. Even when we're using hand tools, we're using hammers, files, hacksaws, safety glasses. I don't want that stuff in your eyes. You do not either. Around these tools, though, we're not wearing loose-fitting clothing, especially when using a portable grinder. There are many, many, many instances on the internet where people have got loose clothing caught in a grinder, and it's not good. I usually show one in class. It's a very safe picture. I don't recommend you Google this on your own. Some pretty gross stuff is going to come up. I had kind of selected a few safe ones for the class, and I often show those. Now, not that it's an issue in our level, but we got to think of some things that can get caught in a grinder. One of the things that a lot of people don't think about is something like a beard. Now, I don't have a beard, and I don't think anyone in my grade 10s do either. If you do, good for you, that's awesome. But beards have been pretty popular lately, and a lot of pictures of grinders stuck in beards have been coming up, or half a beard inside of a grinder, and guy with half a beard on his face. That's something we definitely do not want to have become an issue, especially if we're getting a little older. Say we want to grow a beard, things like that happen. I could apply the same way for ladies with long hair, gentlemen with long hair. But what we mainly deal with in here are hoodies, hoodie strings, earbuds, things like that. We do not want those near any high-speed rotating equipment. What's going to happen is it's going to grab that, and it's going to start to wind up that hoodie string. And we all know those hoodie strings in our hoods sit just below our chin. So that grinder is going to come flying towards our face, and hopefully you are strong enough to stop it. Things could end up real bad, and I don't ever want to see that in my shop. So what I generally do is I tuck in my hoodie strings. I don't wear earbuds. I always wear my denim shop shirts, so that's, keeps things nice and safe. And yeah, that's just one of the ways we can protect ourselves in the shop here. One thing we do need to pay attention to as well, though, is if we are changing discs on a grinder or a pedestal grinder or a hand grinder, any of that stuff, is this bottom point here, that the revolutions per minute, or the RPM rating of the wheel, is suitable for the grinder. So what has to happen is that disc is going to say 15,000 RPM is what it's rated for. Then you're going to put on a grinder. The number on that tool, its RPM rating should be lower than the one on the disc. Because if it's the opposite way, that grinder is going to spin that disc too fast, and that could cause it to have a catastrophic failure in the form of an explosion. And we do not want that. So you always want the rating of the disc you're using, or the stone, to be higher than what your grinder can put out. All right, so here's a pedestal grinder. We got one of these, actually a few of these in the shop. We have them for grinding steel. We have them for grinding tungsten. We have one for actually set up with buffing wheels on it to clean off our steel. But our big one is, though, my main concern here, and it's the most common grinding wheel sizes for a shop or pedestal grinder are 8 to 14 inches. So 8-inch ones, they're not super heavy, but there's a good chunk of material there. Those 14-inch ones, you're looking at 10 pounds of rotating stone on there. It's usually times 2 because we have 2 different sides to the pedestal grinder. So you got 20 pounds of rotating stone there. And if that was to be damaged or cracked and come apart, that's a lot of debris flying at you. These grinders usually run at 1600 to 1750 RPM. These ones don't run at the super high speeds just because of the weight they have to turn, the inertia it takes, things like that. And it's just not safe to run a 14-inch disc at 10,000 RPM. That's just not a good idea. So although 1600 to 1750 RPM does not sound like an excessive speed, the surface of an 8-inch wheel when running at 1750 RPM is about 105 kilometers an hour. So we all know what that feels like. We've all been down the Deerfoot, and that's a lot of speed. And you gotta think that little 8-inch wheel is doing that. So with this here, it's just a kind of a neat little animation. Thought I'd pop in there. It just outlines the safety stuff we're going through here. So face shield is on the top there. We see that. It's got the hard hat. It's got the ear muffs. We don't have to go that crazy in here, but we do have face shields. We do have ear plugs. We do have ear muffs if you want them. We have a welding shield down here, and the front of that can be flipped up to do some grinding with. There is a clear plastic lens on the inside that is impact rated. And then below that, we have our safety goggles. Those are all ways of reducing eye injury. We always wear safety glasses anyways, but when working with something like a pedestal grinder where the chance of something pretty bad flying at us is present, that's when we definitely start to use those face shields. All right. So bench grinders, they are like a big pedestal grinder, but they're smaller. They're generally bolted to the top of a bench. And those wheels come up to 7 inches in diameter. 5 is really common. I've got a couple 7s in the shop. I've got my big one. I've got all my bench grinders actually mounted to stands. So technically I've turned my bench grinders into pedestal grinders, but they still are technically a bench grinder. So most are designed to run about 3,450 RPM. So pretty much double what the, no, a little over double what the 1,600 RPM pedestal grinders are doing. But some are rated as low as 1,600 RPM. At 3,450 RPM, the surface of a 7-inch wheel travels about 120 kilometers an hour. So that's moving. It's moving pretty quick. And here what we have is just a breakdown of a bench grinder. And we got lots of parts and pieces on here. Really important ones are going to be obviously your on-off switch, because we need to know how to turn this on and off. We have our abrasive wheel. Those are important. We can see those on labeled on the left side of the screen, but we got 2 wheels on this one. The tool rest, you can see that on the right side of the screen. That's very important, but that has to be used in conjunction with the wheel guard. Eye shields, manufacturers are required to put some sort of protective device on there. So they put these eye shields on. Are they good? Yes, they're good. Do they get broken and damaged, and do they often get removed from these tools? Yes. So that's why I always implement face shields. These wheel guards, they get mucked up pretty quick, and they just aren't very good as far as providing adequate safety. So I think face shields are best. So that's what we wear in the shop. Those tool rests, though, the ones we see on the right side of the screen, what that is that's where you're going to place your piece of work or whatever you're grinding. You're going to hold it flat against that surface, and you're going to then push it into the wheel lightly, doing the grinding work you need to. If we were just holding it freehand without using the tool rest, we'd end up bouncing our piece all over, not having very good control of it, and potentially risking our fingers or knuckles. There's always a potential of them coming into contact with those wheels, and we don't want that happening. I can tell you this because this is something I've done. I've done silly things by try and grind things freestyle. And I've taken nice chunks out of my knuckles before. It's not cool. They take forever to heal. It's a pain in the butt. And there's always a risk of infection too. So you got to keep those clean if you do injure yourself. But let's try not to. So it should be mounted. So we're talking the tool rest here. It should be mounted so that there is no more than 3 millimeters or 1/8 of an inch between the grinding wheel and the rest. This is to prevent your pieces from being sucked down in between the wheel and the rest, to avoid fingers from sliding into that space, any other things, even gloves. We should never be wearing gloves when we are working on something like a rotating piece of equipment like this. I do allow students to use gloves on these pedestal grinders, but what they must do is they must be using a pair of locking vice grips to hold their material, so that way their hands are an adequate distance away from the rotating stone. Because that stone is rotating in a downward motion, it's going to pull your glove in. If it grabs into your glove, it's going to pull your finger in, and bad news will happen. So you can use gloves if you do not want to get sparks on your hand. These pedestal grinders will throw some sparks. Generally, they don't hurt you. So I almost never use gloves on these at all. If I'm working with a small piece, I will secure it in those vice grips and then do the work on it. But I don't risk my gloves being close to something like the stone and having the potential to have them pulled in. With this tool rest, we're going to align it so that the surface points at or slightly above the center of the grinding wheel. This is just to allow basically not a whole lot of angle on your grind. So if you've got that tool rest way down low and you're setting your piece in there, what it's going to do is it's not going to grind a flat surface on the side. It's going to grind an angle into it. So keeping it at the center is going to help you grind more of a flat surface on it, because most cuts we're making or most things we are grinding, we're going to want to have a flat edge on it. And these wheel guards are required on both bench and pedestal grinders. And those wheel guards cover about 2/3 of the wheel. So the lower portion, the whole backside, and some of the top portion. So we don't need a whole lot of surface to work on. And what this does is just prevents, things from getting pulled in there. Sleeves, people accidentally contacting the back of the wheels. It's all sorts of bad can happen. And it's just, it's very smart to keep those wheels covered. So these grinders are going to have wheel covers on the back of them. You'll see it on the pedestal grinders, the bench grinders, and even angle grinders. They're going to have a guard that covers the majority of the wheel. And this here, it says, just like I said, should cover at least 2/3 of the wheel and extend 30 to 45 degrees past the vertical plane. This just basically makes it so you can work in there without too much issue, or the guard isn't, or the wheel cover is not going to be impeding your ability to do work. So that's kind of a picture of a wheel guard here. And what we see is that 30 to 45 on the top section there. So we're talking from the vertical axis down to one side, and that wheel guard is going to cover the majority of the wheel, at least 2/3. But I like to, do more than that. I only like to have as much of that wheel showing as I need to do my work. And that's generally an amount that looks pretty similar to what we see in this picture here. On that tool rest there, we got to keep it adjusted to within 1/8. That's to prevent things from being sucked in between the guard and the wheel. Could be a finger, could be your workpiece, could be a glove. We don't want that. Grinding wheels. Grinding wheels are classified as to their abrasive type, size, and the bonding material. It's important because wheels are not all made equal. Some wheels are designed for things like bench grinders. Some wheels are designed for angle grinders. And just because it has an arbor hole, that's the hole in the middle of the wheel, that fits onto something doesn't necessarily mean that that is made for that device. On the bigger stones and grinding wheels, what we see is called a blotter. A blotter is a piece of heavy paper attached to each side of the grinding wheel. They serve 3 important functions. So they protect the flanges from getting pinched and crushed. What they also do is they display important information about the wheel maximum size, safe RPM, size of the wheel, outside bore diameter, and wheel thickness. They also talk about the grit, the grade of the wheel, what it's used for, and they can compensate. Those paper blotters also can compensate for uneven surfaces on the side of the wheel. Not all wheels are the same. They're not all made to do the same job. Some are made for grinding tungsten. Some are made with very coarse grit on them for rough grinds. Some are made very fine for fine grinds. Say if you're putting a finish on a blade of some sort, you wouldn't want a big rough nasty finish. You would want a fine sharp finish. So basically these are the pieces of paper you're going to check on the side of a wheel. When you buy these wheels, it'll always have it on it. If the wheel comes in a box, it'll all be marked on the box as well. If you can't read it, I wouldn't use it because you don't know what it's basically for. If it's for aluminum, if it's for steel, if it's for whatever, or its RPM rating. If it's only designed for 1650 RPM and you got a bench grinder running at 3450, that could be a potential disaster. You want it the opposite way. You want that wheel rated for 3450 and you want that grinder rated for 1650, because you always want to have a wheel that can take more than that grinder can put out. Sometimes those wheels, they get a little out of true. Students will be grinding on one side or another, or jam a piece in and kind of creates a little chip in it. Hopefully that never happens. But what we have are these they're called dressing tools. And you run this across the stone or the wheel, and it's going to help even out that surface. Sometimes you turn these on, these wheels will have a vibration to them, and that's not a good thing. Vibration is not good on high-speed rotating equipment. So we use a dressing tool to hopefully address and true the wheel surface. It's kind of like if you've ever been a mechanics and you start to balance a tire, You'll see that tire will have a little wobble in it. And then after the weights go on, it's pretty true. This is kind of the same. Instead of adding things though, we're removing surface material from the wheel. Yeah, basically it's like that. It helps clean up wheels too. If somebody accidentally runs some aluminum on a steel wheel, aluminum is soft. It'll get into that wheel, kind of fill it up. These tools will help you get that aluminum out so you can get that wheel back to original, basically shape. Yeah, and like I mentioned, pruing refers to the removal of material from the cutting face of a wheel so that resultant surface runs flat and parallel. Just makes it nice to operate and use. So replacing the wheel. Check the RPM rating of the new wheel. Very important. Against the RPM rating of the grinder to ensure that the RPM rating of the wheel will not be exceeded. Like I said, your wheel has to have a higher rating than what your grinder can put out. Inspect the wheel for visible defects. And what we do is called a ring test. So what I will do is I will take something like a steel rod and I'll put it through the middle of that wheel. And then I'll take something like a screwdriver, handle, whatever it is, and I will tap that wheel. It should sound a nice clear tone, like they call it a ring test. When there's a crack in that wheel, it's gonna have a dull noise and the sound's not gonna be able to travel around and kind of create the harmonics it would normally. So I'll see if I can find one of these, maybe even take an old wheel and purposely damage it when we come back to class, just to show you what that is. But it's not often we're going to be replacing wheels on these grinders. And if it does happen, it'll be something I do. You won't be doing it. Or if you do end up doing it, you'll be doing it under my supervision. So I will guarantee that this product is good before it goes on to the bench grinder. So a dull tone indicates a wheel may have a crack, should be marked, returned to the manufacturer, or replacement, or discarded. Basically, let me know. Tighten the nut only enough to hold the wheel firmly. When facing a bench or pedestal grinder, the left-hand shaft has a left-hand thread, and the right-hand shaft has a right-hand thread. This is very important. So this stops one wheel from loosening off and flying off, because if both threads ran the same way as per normal, and when we rotated that wheel, one of them would loosen off and that wheel would come flying off. So what we have here is angle grinders. They can be fitted to, angle grinders can be fitted with a flat grinding disc, sanding disc, use with a flexible backing plate or a cup grindstone. So we have lots of different things we can stick onto these hand grinders. We just need to make sure that, like I said, RPM rating is good. We know it's used for, and we know how to use it correctly. Straighter cupped wire wheel brushes. We use those for cleaning off welds. What I've done is I've fitted a bench grinder at the back with 2 big brush wheels that we use to clean off our welds. So that's what we will use instead of a hand grinder with a buffing wheel on it. So in this picture here that we see, starting on the left on the bottom, that's going to be your standard metal grinding disc. Above that, that could be an aluminum grinding disc. Now, different compositions for different discs. Aluminum is much softer and it will fill the pores on a disc and pretty much make it useless. So these aluminum ones are designed to self-clear better. In the middle, on the bottom, we have what's called a flapper disc. That is chunks of sandpaper all laid over each other and glued to a disc. And it does a really nice job of putting a smooth, shiny finish on steel. We use that for finishing though, we don't use it for grinding. A lot of people will use a flapper disc for the whole grinding process and will wear out a flapper disc very prematurely. Above that, we can see a sanding disc. Now this sanding disc is going to be mounted against a flexible back. These are awesome for cleaning things up. They do have a limited lifespan. You can change them out fairly quick. It is a bigger version of a flapper disc, but it just involves a few more parts: the backing plate, the flexible backing, and then your sanding disc. And then on the right side of the screen on the bottom, we have a buffing wheel. Now, those are a twist knot brush is what they're called sometimes. And you get lots of these little wires, each one of those twisted little rope strands. It's probably got about 30 little steel wires in it. So they all get all twisted up into these knots. That helps them not break as much, and basically helps us clean our material off nicer. If those wheels, when they start to go bad, those little wire needles will break off and they'll go flying. So it's often a good idea to be wearing something like a welding jacket in the shop when you are grinding, because those needles will embed themselves in something like a grinding or a welding jacket. Or if you're not wearing that, could be in your t-shirt, could be in your stomach, could be in the front of your thighs. Every now and then when using these, I do find a needle sticking out of my jacket or a shirt or something like that. They just get tossed off as those wheels start to wear. But that is why we wear things like face protection. So on the bottom, that is an angle grinder. 5-inch is pretty common. 7, 9, even 12-inch grinders can be operated by hand. But in here, we generally operate with 4.5 or 5-inch grinders. One thing we do need to be aware of, though, is that we do not fit a 5-inch wheel on a 4.5-inch grinder. That way, when we do that, the RPM ratings are not lining up the way we want, because the 5-inch grinders spin slower than the 4.5-inch. So therefore, the wheels have a lower rating. All right, I'm going to talk about some hand grinders. Hand grinders use rules that are similar to those when using a pedestal grinder. The outside edge of a 5-inch hand grinder may reach speeds around 240 kilometers an hour, so considerably faster. But we're often spinning those 5-inch grinders from 8,500 RPM to 12,500 RPM. They spin considerably faster than the big pedestal grinders at 1,600 RPM. So with these, we're always wearing safety glasses, hearing protection, and a face shield when using these grinders, just because it is, firstly, good practice. Secondly, it's a rule. And if you're not doing that in here, we can provide you the materials to do the work by hand. So we're talking about drill presses. This is called sensitive drill presses. It's sensitive because you feel the whole process. So you're pulling down on the hand feed lever, and that's going to give you feedback through the drill bit. You're going to feel how it's cutting. You feel when you cut through the material. That's why it's called sensitive, because you determine how much pressure you apply by the feedback you get from this, this cutting bit. So for the most part, pretty standard. It's not too different from anyone you may have seen in the construction shop. We have our base, we have our column, table clamp, we have our table, we've got our chuck, our hand feed lever, there's spindle, depth stop, and drilling head. The one thing you will find is that the ones in the fabrication shop are much heavier built than the ones in the woodworking shop. Steel is obviously much harder and it requires a lot more torque to do the work. So we overbuild things so that we don't have a failure of a component, and then we're not getting an injury from that. It has no power assisted feed. So basically you have to feed it down into the work by hand. That's where you get the feedback. That's why it's called the sensitive drill press. It says it allows you to sense the cutting pressure on the drill. Drilling machines and twist drills. When you are using a drilling machine, follow these safety guidelines. So never attempt to hold your work by hand. Electric motors have immense amounts of torque. That's why Teslas take off so darn fast. And we've all seen those videos on YouTube where Teslas just smoke all these cars off the line. Well, that's the beauty of an electric motor, instant torque. That applies to drill presses, that applies to hand drills, that applies to angle grinders, as well as pedestal grinders. So we never want to hold anything by hand, because you are not going to win that battle. It's just not worth it. You want to keep your head and body well back from the revolving parts of the drill to prevent your hair or clothing from being caught. We're going to throw it back a year, maybe 2 years here. So there's a viral video on the internet, young lady trying to eat some corn off of a drill. I don't know if you guys remember seeing that. She's got this drill spinning, hair gets stuck in there and it rips out a big chunk of her hair. Yeah, that is completely and entirely possible. And the thing is, if it's a drill press and you've hit the on button, there is no trigger to let go. You have to hit the stop button. So that's going to continue spinning that whole time until the stop button's hit. And let me tell you, there are some and have been some horrible injuries throughout history with these. I'm not going to encourage you to look any of those up because it is almost lunchtime and you guys want to have an appetite for lunch. So never attempt to grab work that may have caught in the drill. Sometimes it'll pop out of the vise and it'll be sitting there spinning away. Don't try and grab that work. Hit the stop button, step back, get out of the way. If that goes flying, you don't want it to hit you. As the drill begins to break through the work though, if you are drilling and you feel it start to come out the bottom, and with metal drills, you can hear a couple little cracks. It'll lighten up a little bit. That's you popping through the bottom of that plate. Ease up a little bit on the pressure and just allow the drill to come through gradually. Don't force it through. It's not going to work out well. Sorry, 1 second. This minimizes the risk of the drill bit grabbing the work and breaking the drill bit. So yeah, if it's not taking our piece out of the vise and spinning it, there's a good chance we're going to break that drill bit. These are hardened steel. And what's going to happen is that drill bit's going to explode and shatter. And it's going to send shards of tool steel in every direction. And they're going to be like little razor blades flying through the air. So you do not want to have that happen. It's happened to me. I've received cuts from these. And it happens so fast, you don't even know it until all of a sudden you're bleeding out of your cheek and you're like, huh, I wonder how this happened. Yeah, been there, done that. So hand drills, we got a bunch of different ones. Ours are a little more new than this one in the picture. So we do have corded hand drills. So they're running on AC power, which means they're plugged into a wall, 120 volt. We have DC ones that are battery operated, and then we have air operated ones as well. We don't use the air operated ones near as much. You'll see a lot of those in like auto body shops, things like that, or machine shops, but I use electric drills in here.
Motorsports is where you also find pneumatic, I guess, stuff.
Pardon?
In motorsports, you also see pneumatic stuff, pneumatically powered drills and all that stuff.
Yeah, definitely, because they're gonna always have air around for compressor purposes, stuff like that. So yeah, that does make a lot of sense there. That definitely works. Yeah, ours are definitely a little more new than this one in this picture here. But yeah, we can operate, air drills. We can operate battery operated and electric drills in here as well. On these drills, the chucks are going to range from 1/4 inch to 3/4 inch in size. If we do have a larger drill in here, it's going to have 2 handles on it, and that's for running bigger bits so you can support it. If you just had a single hand on a 1/2 inch drill bit or a 1/2 inch chuck, and so you're running a 3/4 inch drill bit and it caught, there's a good chance it could twist your arm quite hard, potentially causing some damage, maybe even breaking an arm. So we don't want that. That's why those ones have 2 handles, but we generally don't use them in the shop. We have drill presses and we will use those tools, which are much safer than doing this by hand. But we will need to drill some holes at some point. So we do have some battery operated drills for that. Portable hand drills are rated by their chuck size. That's going to be important. There will be a quiz on this coming up probably tomorrow. So I'm going to make sure that's all good. Everything aligns in the quiz. But yeah, so that is important to know. Some hand drills have reversible motors and variable speed capabilities. This is pretty common in all drills nowadays, but it wasn't quite the case back in the day. Hand drills with 1/2 inch chucks or larger usually incorporate a second handle mounted sideways at the front of the body for extra support. Often they'll have a handle on the back, like a D-ring style handle, and then they'll have a fixed handle on the top side of it. So you can hold the drill in various different ways. But we're not gonna have to worry about that. I'll show you one when you get here, but we're not gonna have to worry about using one in here. So we got a key type drill chuck. We kind of know what these are. Basically, we have a key that fits in the chuck. The chuck is normally 3-jawed. 3 jaws will hold the drill bit in place. Important thing with this is we must make sure that the drill bit is centered in between the 3 jaws, or it will not cut that nice hole for us. It'll spin and it'll kind of scratch a circle on the surface of whatever we're trying to drill. So 3-jaw type chucks are most common, may be adjusted in and out to grip onto the shank of a straight shank, twist drill, or other accessory. Sometimes people will put like a buffing wheel on there and then they'll use it as a portable buffing stand. I just use those tools as they're intended, so I only use them for twist drills. A key is used to tighten the tool in the chuck to make sure to remove the chuck key after tightening. So you see in the gentleman's hand a little tool there that's tightening up the chuck key, or the chuck, that's called the chuck key. Ours have a spring-loaded tip on them. So if you try and leave it in the chuck, what's going to happen is that's going to pop it right out of the chuck, because if it's in there and we turn that thing on, it will most likely start to wrap up. It'll break the chain. It'll spin the chain around like some spinning death wheel in your face, and then probably eject that chuck key at some point, and who knows where that's going to go. So we don't want that. So that's why I have the spring-loaded chuck keys, and they're going to pop out of that chuck, keeping us safe. But I do like to keep the chains on them. That just keeps the chuck keys attached to the drill itself. That way we don't lose them. So drill chucks are sized according to the largest twist drill they can hold. Normally come in sizes ranging from 1/4 to 3/4 of an inch. Keyless chucks, we see these more on lathes. So they work well on lathes. And that's how we drill bigger holes and things. So keyless chucks are operated by hand, turning an external collar. They do not grip tightly as key type chucks, but hold well enough for light work. I kind of like these. The key type chucks are good, but I like the keyless chucks because sometimes drill bits will get stuck and they'll be allowed to spin within this chuck. It's not just going to twist that drill till it breaks. So they've got their positives and they also have their downsides. So anatomy of a drill bit here. What we have is we got the point. That is the cutting end, the working end. The body is this going to be the length, the fluted length of the drill bit. We can see flutes are those spiral curls around the length there on the body side of it. And the shank is basically what's going to fit in your chuck. A lot of them are tapered. You can see this one is tapered. And to remove these, we use a key, a wedge-shaped key, and we'll tap it at the top. It'll pop these out the bottom. A lot of these ones, bigger ones, are used in machining purposes for working on something like a lathe.
Hello, I do. Good, and you?
Twist drills are also known as drill bits, and they consist of 3 main parts. We talked about those. We got the shank. You see that at the back. We got the taper shank. We got the tang. Straight shank. These ones here on the bottom are going to be more common in the shop. A twist drill is held in the hand drill or a drill press by its shank, of which there are 2 types. Yeah, we saw those. Straight, taper, and lubricants and cutting fluids. 1 part soluble oil cutting fluid, 25 to 25 parts water is a common ratio. What this is when we got metal on metal, that's a lot of friction, a lot of heat, especially if you're cutting steel with steel. Heat is the enemy of hardening when it comes to drill bits and any cutting tools and even motors. You don't want heat in motors. You don't want steel wearing on steel, stuff like that. So what we do is we use a cutting fluid to help preserve the life of our drill bits because they can be quite expensive. This also just makes cutting easier and is generally just makes the process a little nicer. We use this for pretty much all drilling processes. We've got thicker stuff, we got thinner stuff. You know, you can use it with hand drills, you can use it with big drill presses. It's not only for one certain type of thing, but some of these can be used for several materials. So we're talking the cutting fluids, and others are designed for one type of material only. So moving on past that, what we have here is a chop saw or a cutoff saw. And the way these work is we have a giant spinning blade of death here. And it's not that scary, actually. They're just noisy and they make a lot of sparks. But what this wheel does is it's an abrasive cutoff wheel. It could be 14 inches diameter, it could be 12. I've got a whole bunch of them in the shop here. And I've got one of these chop saws or steel cutoff saw. And it's pretty much operated like a miter saw in the woodworking shop. You have a handle with a trigger, you can see here. Squeeze the trigger, your piece is going to be clamped here within these jaws. You're going to cut on through. It's going to make a lot of noise and sparks out the back. Ear protection, eye protection, a must when using one of these. It's good for cutting a lot of smaller stuff. I do have a nice metal cutting bandsaw on here, so I don't use my steel chop saw very much at all. So here we have a nice bandsaw. A little nicer than mine, that's for sure, but ours works just fine for what we're doing here. So bandsaws are pretty awesome, great tool. They're basically hacksaws on steroids. You guys will find out how fun hacksaws are shortly here, and then you're going to be very grateful for this tool afterwards. Horizontal bandsaws offer a significant advantage because once you're set up and started, they leave you free to perform other duties. So mine has an automatic stop on the bottom. When you're done cutting, the blade will stop, it'll shut the motor off. You can then lift it up, slide the next piece in, start it, you can walk away, come back when it's done. I generally don't go too far away because if something does happen, I need to be able to shut that machine down quickly. But it is nice because you don't have to sit there and babysit the saw for every second it's cutting. Some units even have an automatic self-feed system, so they'll continue to cut until they run out of material. That would be nice. Some of them, when you program them, they will just keep feeding material in and cut and cut and cut until they don't have any more material on deck to load. All right, so if you're a little squeamish, I will get you to look away right now because this is what can happen if you're wearing something like a ring in the shop. So that is what's called degloving. That is where the ring gets caught on something and is pulled towards the end of the finger. Well, gold is soft, but flesh is a lot softer. So what happens is that finger starts to slide. And I don't know if you guys can see it, but right here is the edge of a gold ring underneath that flap of skin that has been slid down. So not a cool thing. I've got a bad habit of wearing mine in the shop. I need to break that habit because I do not want to end up like this guy. I like all 10 of my fingers equally. So we're past that now, so you can look back if you were looking away. Occupational health and safety allows that person may refuse unsafe work. So this kind of more applies to you when you're in the workspace. But if you are working for an employer and the employer says, hey, I need you to go crawl under this car here and I need you to weld this muffler on, but we don't have any proper blocks or jacks, so we just kind of propped it up with some 2x4s. You know, it should be fine. Just go under there and do that. You know, that should be setting off some alarms in your head, and you should be saying, hey, no way, I'm not going to do that. It's not safe. And you're completely within your right to say that. If the situation is truly unsafe, then you have all the grounds in the world to not perform that task. If it's something that you perceive as unsafe, but actually is safe, if it can be proven to be safe, then you will need to complete that work. But if you're not comfortable doing it, oftentimes you can let a boss know and they can have somebody else complete that work. But if it is something that is truly unsafe, you know, hey, I just need to go down in this hole here that we haven't done any gas testing in, and there's a few barrels of gasoline in the bottom, and just weld this one little thing, probably not the best idea, right? So you've got full grounds to say no in a situation like that. So that's that for the slideshow. Any questions? Anything that wasn't clear for you guys? Anything you're having trouble with? Okay, so if that is the case, we're going to stop sharing this here. What I'm going to do is I'm going to make sure this is available for you in your Brightspace. So this should be open. So you will now see a new section under Power Tools Safety. It will be visible, and within there will be the Power Tools Safety PowerPoint. It's the one we just went over. And tomorrow we're going to have a quiz loaded up in there, probably 15 questions. You will be able to complete that using the Power Tools slideshow. So that'll be basically tomorrow's work session for us. Overall, pretty simple. It's a lot of basics. You may have learned some of this in some other courses, maybe construction, maybe some CTF in junior high, but it applies and it's only there for your safety. I don't want to see anybody hurt in my shop. I've been very fortunate so far with having nobody get hurt, but it's staying diligent, staying active in the safety role here. That's going to prevent these incidents from happening. So you guys are out 15 minutes early-ish. If you have not dropped your name in the chat, please do so. If you have, you are free to go and enjoy your lunch. So I want to say thank you for everyone for coming in. It's a beautiful day outside. If you can get out there, enjoy the sun a little bit. And yeah, just make sure you're getting all your work done. Be nice to your teachers and have a great day, folks. I will see you online tomorrow at our normal scheduled time. Today was weird because we had to TA, but we'll be in our normal time tomorrow. Okay, see you everyone. Have a great day. I'm going to leave this open for a few minutes. If you guys need, I will be here for, I'll be here for any questions you guys have. And yeah, I'll see you guys tomorrow. Thanks.
Bye, mister.
Bye.
Bye, sir.
Bye, everyone. See ya. Have a good day. Stay healthy.